Hi, this is RJ Visser here at A Lot of Bits. In this video, I would like to discuss how to build interactive data mining dashboards with Python in the context of organization and efficiency improvements. I use Python to build these dashboards since it offers many free libraries in terms of data analysis and the creation of charts. However, creating an easy to customize, high-performance web application with Python using event triggers from the charts did require some trial and error, and it took me some time to find the right components to use. So I thought it would be useful to share with you how this can be done and save you some time if you are trying to do the same. Before diving into the details, I would like to spend a few words on why you would want to use such a dashboard in the first place. In my view, these dashboards are a critical part of a continuous learning curve of an organization and can therefore be instrumental for their competitiveness. While process-related metrics never should become a goal by themselves, they can provide great insights to identify what can be done to improve things, supporting a data-driven learning curve at all layers of the organization. Typically, looking at the value of a single metric does not provide you with the necessary insights needed to identify improvement opportunities. In most cases, you will need to be able to look at the trends over time and at the data behind the trends in various ways. This is why I started to look for a way to build interactive data mining dashboards. So let's take a look at an example of one of these components that could be used on such a dashboard and see how it is built. To illustrate the flexibility and the performance of the approach, I figured flow efficiency would be a great example to take. Flow efficiency is a well-known metric used, for instance, in skilled agile organizations and is defined as the ratio between the total active time an organization has worked on an item and the time it took the organization to deliver the item. In this particular case, we've created 3 layers to analyze the data, and I'll walk you through each one of them. At the top layer, we can see the trend in flow efficiency. Here we have the option to change the issue type, epic, features or stories. We can change the window over which the statistics are collected, and of course the total time frame of the chart. From here we can zero in and look at the details behind the chart. Here we see the volume distribution of features delivered in the 3 sprints leading up to the end of sprint 12. At this level, again, we can change the issue type, the window over which the statistics are collected, and the sprint number that we're interested in. So let's take a look at this one epic. Here we see a Gantt chart, showing the epic is built up out of 1, 2, 3, 4, 5 features, with each feature built up by various stories. By the way, the data you see in these charts is not related to a real organization, as that will be too sensitive to share. To generate this data, I built a digital twin of an organization consisting of various teams at the epic, feature and story level and simulated their activities over time. Had this been a real organization, I would have taken a closer look at the prioritization and capacity allocation with the feature teams, as the idle time at this level is severe and it pulls down the overall efficiency of the organization. Even at this level, the dashboard offers various ways to select alternative views. We can change the percentage range, the window during which the items have been finished prior to the end of the selected sprint number, and of course, the selection of the issue type. Changes made to the selection criteria are also retained at the higher aggregation levels to allow for consistency in the analysis. I hope that this example illustrates that an interactive data mining dashboard needs to provide for many different ways to interact with the available data to allow the user to identify the main areas of improvements. This large flexibility in combination with the need to have a responsive interface puts specific requirements on the approach to take. In many cases, dashboards preload a lot of data to the front end in an effort to maximize responsiveness. The downside of that approach is that it limits the scope of the data it can present, as there is a practical limit to the amount of data one can preload. In order to maximize the scope, I decided to minimize the amount of data sent to the front end. This means that new data needs to be fetched each time the user interacts with the interface. The responsiveness of the interface then depends on the latency of the call and response cycle, and we'll need to optimize the data infrastructure with that in mind. Fortunately, When dealing with process-related data, the data structure is typically highly linked, ideal to be implemented in a graph database which is optimized to handle this. So here's an example of what it could look like in Memgraph. I'm using Memgraph Lab to visualize the data. I'll run a quick query to do a snapshot of the data available. Of course, there is a lot more data in the database than what I'm showing here, but this will give you a view of the data structure. Let me clean it up a bit. So what I did here is I selected one epoch and one particular point in time. As you can see, the epoch is built up out of two features, and the features are built up out of stories. There are tasks associated with it, there are statuses associated with it, and you can see a very, very highly linked structure, which is exactly the reason why we use the graph database to capture this data. There is a lot more data behind each one of those nodes. I'll provide you a little bit of a snapshot here as to what we are dealing with. So you can see that this story has test cases associated with it. There were 2 bugs logged to it. There are many, many different statuses and of course different tasks. And each one of those nodes will have a very, very large data set behind it. But I wanted to illustrate this structure at least to show the highly linked nature of the data set, which is the reason why we picked a graph database, as this will allow for a very fast call and response cycle when we query the database for our dashboards. Memgraph was selected as a result of the performance it offers. It is written in C++ with a focus on high throughput and low latency, exactly what we needed for the implementation of our interactive data mining dashboard, where we minimize the data sent to the front end and need a very fast call and response cycle with the database. To implement the web application, I selected Streamlit. Streamlit is a pure Python solution to create web applications. It has well-documented structure to allow you to build interactive applications entirely with Python. Here is a quick overview of the API reference related to Streamlit. As you can see, it provides for many different elements which you can easily include in your web application. One of the third-party plugins allows you to incorporate Echarts. I selected Echarts as this provides an attractive, clean graphical representations out of the box, and it offered me a way to use events from the charts as part of the interaction with the user. If needed, it is also possible to add details with JavaScript, so kind of the best of both worlds between Python and JavaScript. In tying all elements together, this is what the pipeline could look like. If your team is using Jira, we can extract, transform and load the appropriate data into Memgraph on a real-time basis. Memgraph will then hold all the relevant and historic data to support the interactive data mining dashboard. With Streamlit and Echarts, we can then easily create suitable representations on the dashboard with full access to all available process-related data. In this video, we looked at building an interactive data mining dashboard using license-free Python scripts and libraries. By minimizing the data loaded into the front end, we created maximum flexibility to explore the available data. This approach requires an optimized data infrastructure. With Memgraph, we realized the low-latency, high-throughput database we needed for this approach. It has a well-established Python interface, and within Python, we use Streamlit and Echarts to build the interactive web applications. The combination of these 3 components allow for the design of custom, high-performance dashboards which are easy to design and maintain. As mentioned in the beginning of this video, I believe an interactive data mining dashboard can be a great tool to identify opportunities for improvement and support a continuous learning curve in your organization. I hope this video has given you enough pointers to get started with this cost-effective implementation using Memgraph and Python scripts. If you need help with any implementation of your use case, feel free to reach out. I'd be happy to assist.